A parabola is the graph of a quadratic. So we're going to go ahead and begin with the standard form of a quadratic equation, which has been on every set of our notes for this module, where a, b, and c are coefficients. We've seen this equal to 0 many times, and so when the standard form is equal to 0, we do that when we're looking for roots or solutions or other types of things that we'll see later on. So a parabola is what we call a conic section, and it's a special type of graph that's formed by intersections of shapes. It's very fascinating, and you'll go deeper into it in calculus. Suffice it to say that there's a couple of ways to graph a parabola. We're going to focus on the more simpler way, and that's the vertex form. Now, this is the vertex form of a quadratic. So notice that there's no b and there's no c. This time it's replaced with h and k. Now, you can take any quadratic and make it into the vertex form by using a process called completing the square, which we're not going to do in these videos. What's important to note is this is called the vertex form because you can pull out this value h and this value k, and it forms what's called the vertex. The vertex is pretty much the turning point. It's kind of like the mirror point of the entire graph. So notice that there's a minus in here, but it comes out as a plus, and then whatever sign is the k value is whatever sign the k ends up having in the vertex form. This is pretty much your x value, quote unquote, and this is your y value, quote unquote. So what does a parabola look like? Well, let's draw you a few. Here's a parabola. It's a U shape. They can also be sideways. We're not going to focus on the ones sideways in this class. So a U, right? It's either a happy face or a sad face, pretty much, right? Happy, sad. And what's interesting is this point right here, right? This point is called a vertex. It's kind of that turning point. It's either the highest point or the lowest point. Please be mindful that these parabolas, of course, do have arrows. So these go on forever in the up direction, left and right, or forever in the down direction, left and right. But there is this point at which it kind of peaks or it kind of goes the lowest. In this case, this is the lowest point, and so we call this vertex a minimum. And in this case, this vertex is the highest point, which we will call a maximum. Now, this parabola over here is actually not a function. If you recall the vertical line test, it hits it in two spots. And so if we draw a vertical line and the graph intersects it at more than one point, then this is not a function. So we're not going to even worry about these or focus on these in this class. We're going to focus on these two to the left. Problem 3 will be left as an exercise for you to work on. So go ahead and check that out in Canvas. Be sure to follow those instructions and fill out this portion of the notes as you do that assignment. So at this point, if you want to pause and go catch up on that or go review that, you're very much welcome to. Otherwise, for your summary, no words this time, a little bit of art. Draw an example of a parabola that has a minimum, and go ahead and label that vertex minimum. So please stop the video if you haven't done problem 3 yet. You need to do problem 3, do the assignment, fill out the notes. Otherwise, this is not going to make sense. So please go do problem 3 if you haven't. Okay. Now, we have many graphs to graph. Notice some of them have parentheses, some of them don't. Some of them are missing numbers. Some of them barely have anything. We're going to follow pretty much the same process for all these. First, we're not going to use Desmos or anything else to graph them. I need you to understand how to graph them. I know that Desmos knows, but do you know? Second, I need you to recognize that we're not going to do this a traditional way where we make a t-chart, right? So usually your teachers will be like, okay, what if x is 0? What if y is 0? What if it's -1? What is, we're not going to do that. That's because that means I have to plug in a 0 into here. I have to pray that you know how to do order of operations and get this value right. Then you got to do it again, by doing this 0 instead and solving this for x. And it just becomes too much. Third, be mindful that what I'm showing you is pretty much bootleg math, but it works. It only works if you follow it. You don't ask how a person got a bootleg movie. You just watch it and enjoy it. So, watch and enjoy. First, we're going to identify the vertex, HK. So, for A, our vertex is going to be positive 1 and positive 1. This positive 1 is K, but the inside of these parentheses, I take the opposite number. And that's where that positive 1 came from. For example, with B, it's positive 1, negative 3. For C, notice this is a positive. So the vertex is negative 1 and then the positive 1 out here. Okay. So we're showing you how to find the vertex. We haven't graphed yet. The instructions are to graph. So don't think, oh, we're done with A, B, and C. We're not done. Step 1 is to identify the vertex. Okay, which is actually probably most of the math we're going to do for this graphing, is what we just did. Find the vertex. Great. Next, decide if the parabola opens upward or downward. So we're doing the second step. This is A. And if you look back at problem 3, part A, it asks you, how does the sign of A affect the graph? Well, if I see this as a positive 2, that means the graph is opening upward. So in this case, it's opening upward. There wasn't no math for that pretty much. Okay. And then finally, our third step. Is this narrow or wide? Well, let's go ahead and kind of do that and do some cheap points, what I call cheap points. Again, you're not going to find this anywhere else. Let's go ahead and graph. We always start with the vertex. That's 1, 1. So here's 1, 1. That's our vertex. This graph is going to open upward. But how does this 2 affect it? Well, check this out. Here is what I call cheap points. So this is definitely a point on this parabola. I'm going to go 1 over and 2 up. And then from here I'm going to go 1 over and 2 up. That's a point. That's a point. Connect them. We're done graphing. That's it. That's it. Now, Mr. Where did you get that 1, 2 thing? Well, it's not always going to be 1, 2. In this case, it's going to be 2 because of this 2 out here. So I always go 1 to the left or 1 to the right, and then I go 2 up. Like for B, we're going to go ahead and go 1 to the right and then go 5 up. Okay. So that's it. I mean, you might need to pause and replay that because it was so fast. I'd like to challenge you to try out part B. Graph it like we just did.